Okay, people over Zoom, we have a small party. So if you join next time, maybe we still have some chocolate left for you guys. But anyway, okay. Today we continue our discussion over Hadoop ecosystem. We learn more technologies. Regarding to your assignment, it seems Cloudera has some server issues. So for some reasons, some of you couldn't run some of the codes through Cloudera or Horton Sandbox. So that's fine. Even if you run it locally, it should be fine. Later, we learn other platforms that hopefully you don't get any company error. Especially you in the previous slide, we have learned how to install locally. So I don't expect you guys to do assignment right now through the local installation of Hadoop, but later through the local installation, you don't get any error because it just depends on your system. So for the assignment, I don't want you guys to lose any credit for the thing that's not your fault. So that's totally fine. And just run through the local Python installation. Oh, we don't have. Project. So this is the overall. I mean, there's different figures for Hadoop ecosystem. It's one of them. So as you see, the base is Hadoop Hdfs. Hadoop Hdfs stands for Hadoop File System. So it's just basically multiple nodes that works in parallel. Each node has a copy of your data. Then on top of Hadoop file system, we have Yarn that runs MapReduce for ourselves. Also, we have Hbase. So as you see, Hbase could connect to Hadoop file system directly, not through Yarn. Some of them goes through Yarn. Also, as you see, we have like elephant, pig, hive, like whale. So we also have the ZooKeeper. If I simplify it, it just keeps those animals. But it's similar to operating system like Windows or Mac OS. Basically, it just manages all those technologies. So which one should be run, how to send data or commands through maybe Spark, Yarn, and Hadoop file system. Also, at the bottom of figure, we have Kafka, Flume, and Sqoop. This green one is the Sqoop. These are some technologies that let you to basically load your data into Hadoop file system. So more specific for more advanced or more complicated data, so Sqoop and Kafka lets you easily load your data from your local system into Hadoop. Basically, you can even do it without them if your data is very basic, but these technologies help you to do it much faster. So at the end of the day, we have some overall understanding of these technologies. But for your project, you basically do it through Spark. So look on the right side of the figure. So we have Apache Spark. On top of that, we have Spark Streaming, Graphics, Spark SQL, and Spark ML. So, and I assume most of your focus on your project is through Spark ML. So basically, it's just a package. So, for example, you want to predict something or classification, prediction. All of those are some semi-Python codes through Spark mlib. And also, if you know R, there is R Spark 2, Spark R2. So you can use another package to connect to Spark Apache. send your command. Spark Apache goes through Yarn for doing MapReduce, and Yarn connects to Hadoop. So this is just the overall. Since most of your projects should and would be through Spark MLlib, most of our time, our focus would be on that part. So you learn how to do coding for a Hadoop ecosystem through Spark technology. If you end up working as a data analyst or data manager at Google, maybe you work with Hbase a lot, but even at Google, maybe still you spend a lot of time working with Spark. You also learn a little bit of Pig, Hive, Mahout, maybe a little bit of Hbase or Sqoop, but these are not our focus. You just skim through them. So if you are interested, you can spend some extra time. And on top of even this technology, there's other technologies that work with Hadoop ecosystem that you can learn by yourself. Any questions so far? Let me wait for your friends over Zoom. So if you have questions about your project or assignments, you can ask me too. Since I don't see your friend's face, just let's wait a little bit. So in case they have questions, they can ask. Yeah.
So you mentioned that we should address an analytic problem in our final project. So it could be the prediction or the classification, or we can choose a data set to the post. Right?
What data set?
I mean, like we just like choose a data set and we could post the prediction.
Yeah, you can. So what I mean, this is our focus. So for example, you had one assignment on doing MapReduce through Python, doing by yourself without using Yarn. I mean, the goal is just knowing that how it's difficult. I didn't want to torture you guys to just do everything through that. So, it means that assignment is not a big deal. So the big deal later on this course, you can do some machine learning through Spark environment or Spark technology.
Is there any requirements for data science?
I mean, no. At least you should have, what I recommend, have maybe like 10 variables and number of records, maybe at least 1,000. But your learning is I just evaluate you through your project through Spark. And I want to know that you are able to code and do analytics using that. If your data set is larger, it just helps you for your practice, but it's not necessary.
So we need to necessarily use Spark in our project.
If you don't, your life is much harder. I mean, and I can say almost near impossible, because let's say you want to do prediction using MapReduce or everything by yourself. That's much harder. So you learn how to do either R or Python through Spark. So there is some similarities between R and Python, but it's not exactly the same. The logic is kind of different.
And it has to be necessarily a
prediction, classification, even visualization, one analytical project. Okay, let's see if your friends, I don't see if they have any questions. So these are the general applications and tools that you see in the Hadoop ecosystem, some for data analysis, especially some Spark packages that you do prediction, visualization, database integrations. So I talk about Sqoop and Flume and other technologies that let you to integrate external databases with basically internal Hadoop file system, and also we have workflow management. Some part of the technology is related to managing your resources, like ZooKeeper, that let you to schedule basically execution of different parts of Hadoop ecosystem. So basically, these are some, the ecosystem is not the main part of the Hadoop. The Hadoop core is just Hadoop file system, yarn, and the MapReduce. So the other external tools, so first 2 or 3 level, which is data HDFS, yarn, and MapReduce, these are the Hadoop core. The remaining are the technologies that makes your life easier. So let's look at Peak. So one of the one part of Hadoop ecosystem is Peak. So again, instead of doing for managing your data, instead of doing everything through MapReduce, you can use Peak. So as you see, the codes kind of similar to simple scripting codes. You don't see any map reduce, those kind of things. It's very good for joining different data sets, and basically the script name is Peak Latin, and Peak just convert those Peak Latin script to some MapReduce jobs and basically submit those jobs to the cluster and run MapReduce and work with the Hadoop file system. Another technology is Apache Hive. It's similar to Peak and Peak Latin. The script is a script language. You look at the script, isn't it similar to SQL? So instead of doing everything through MapReduce, you do something similar to SQL. So you don't have that much of learning curve working with Hive. And using those scripts, you can do whatever, some similar things that you already learned through SQL Server. Okay, the other one is Apache Hbase. It's very good working with a very, very large data, so gigabyte, terabytes. And the logic behind of this data set is columnar data format, which instead of considering rows, you just read the data and record through columns. The advantages is you can do very advanced NoSQL queries. So NoSQL just means the data are not in the rows and columns, and you don't have keys. So like text document. So text document is a data. So many information might be in it, but the data is not in the SQL format. So having said that, if you look at here, Hbase connect to Hadoop file system directly, right? So what does it mean? So you don't have extra layer of yarn and MapReduce. You can connect directly. So it just makes it much faster because it doesn't need to convert to multiple different types of code. But at the same time, coding with Hbase is much harder. So you need to figure out some part of MapReduce, and not you don't have to do everything in details, but still, since you connect to Hdfs, it's at the same time is much faster, and also coding with Hbase is much harder. As I said, you might end up working Google. So it's Hbase developed by Google, and they need to work with the terabytes of data and even much more than that. So they need something faster so they can do queries much faster. Okay, the next technology is Apache Scoop. The name is fun. It's like a scooping data from RMDBS or SQL-based data set into a Hadoop file system. So I think this figure makes it clear. So you have an external RMDBS, relational database system file. So Sqoop just get that data, read it, and upload into Hadoop cluster. So as you see, you might later within the Hadoop, this file would be copied on multiple nodes and clusters. And for prior processing, probably you can do it much faster. Here I put a snapshot of the codes. So it's not exactly similar. There's some differences between this Sqoop and SQL, but as you see, if you look at the first part, you connect to a local server and you import your username and password, the destination folder, and the last one, you tell the table name. Because it was a relational database, so data is in the table. So having said that, it seems cumbersome because you need to hide, but at the end, I think it's very straightforward. So username and path, destination folder, and just the destination table name. So today class might be a little boring because I just skimmed through some technologies, but hopefully from next class, again, we get to some hands-on experiences, so it makes life much easier. But sorry, for this, because I have to go through this concepts. Sqoop also lets you to work with a columnar type of data set. And you also can basically edit your data set, in terms of adding new basically rows and columns, but it's not that much time efficient. So Sqoop, although helps to do that, but it's not as time efficient of other technologies. So another technology for importing your data is Apache Flume. So I can say it's a basically advanced version of a Sqoop. So it helps you to import a stream of data, not just a one big data set, into Hadoop file system. And the data could be from different resources. So programmable, log files, maybe some Facebook even can use it for basically import the data. So the advantage of Flume is just working multiple data sets and working the data in parallel. Sqoop also is advanced one, but Sqoop is just for dumping a large data set who's basically a standalone large data set. I think here this figure clears differences of Hadoop and Sqoop. So as you see, the bottom data set, we have a relational data set and data warehouse, so two large data sets. So with a Sqoop, is very efficient to upload them into your cluster through a Sqoop. But if you have a web app or web or app servers like Facebook, who basically at each second makes several data through, or a stream of data like tweets. So you need Flume helps you in a very efficient way, so you can import a stream of data into Hadoop cluster. Also, files could come from other Hadoop Base file systems, so you don't have to use any technology. So you can easily connect another Hadoop file system to your current clusters, and the command is much easier. Another technology is Apache OZ or Uzi. Basically, it controls and coordinates execution of several commands and jobs within your system. It includes MapReduce, even peak or Hive. They are controlled over by using Uzi. And I think in the previous case I talked about Java, which is the language that they develop Hadoop. So Uzi also controls Java executions, control file system, and any basically email, command, everything that is running on your Hadoop ecosystem is controlled by Uzi. So one of the developers of Hadoop ecosystem is Cloudera, and Cloudera had a big competitor, which was Hortonworks. So they already bought Hortonworks, and the sandbox, or I mean the virtual machine that you work with, is developed by Horton. But since Cloudera purchased Horton, so you download the file to the Cloudera website. These are some, I got this slide from Cloudera, so they just put some ads there, like they said, most complete tested, widely developed distribution of Hadoop. But I think through the last assignment, some of you may not believe it. And basically the virtual machine that you see is through, I think it's Ubuntu, or I'm not sure, but it's one of the installation, one of the instance, they use one of the instances of Linux to develop that virtual machine that you already use. So frankly speaking, Cloudera is a really good company. As you see, I mean, maybe in future, if you work in a company, they make a contact with Cloudera. So, and sometimes you get any issues, you can call the company, because you would use the paid version of Cloudera. And so hopefully you don't get the errors that you experienced through the virtual machine. So having said that, so far we had three different delivery of Hadoop ecosystem. One was through VirtualBox, which is a free version of the Cloudera or Horton. I think it was originally made by Hortonworks. But another one, you might work in a company that they make a contract, they use the paid version of Cloudera. So that makes your life easier. But so far, these two versions are these are the versions that you purchase and use it internally. So you might have, your company might buy several clusters, servers, and they don't want to use other services. So they may reach Cloudera, and hopefully you have some experience with the virtual machine, I mean the free version of it. So later, if you work with the actual paid version of Cloudera, your life should be much easier. Hopefully you don't get any error. So also we had local installation of Hadoop ecosystem through Apache Hadoop project. So this kind of installation also are great, they're free, and also there's a community behind of it. So anytime they see any bug or error, they just post to the community and they fix it. Also, many times if you get any issue through that, you can just Google your error and most likely you can easily fix it. Later in the course, we learn another versions of Hadoop ecosystem through Databricks, Amazon AWS, and Google. So for most likely, if you end up working in the startups, I don't think they purchase Cloudera because usually they are not big companies. In the other, also they usually they don't want to hire somebody who knows core of the Hadoop ecosystem. Instead, they may use AWS, Databricks, or other platforms. So in those platforms, you upload your data on the cloud, and you need to do some analytics over very big data. For those type of companies, which I think Shashank, your alumni, joined, so their focus are, they don't spend too much of time on Sqoop, MapReduce, file system, peak, so on and so forth. So they connect to a cloud, upload their large data set there, and they use just a Spark environment to run their own codes. So these are for smaller type of companies. For larger ones, they either do they want to have the local instance of Hadoop ecosystem. So they might buy several servers and clusters. For that type of business, they either use cloud or paid services, or they use Apache open source community version, and they may hire somebody who knows very core of Hadoop ecosystem. Okay, so I put some links for further study. First one is a recorded presentation. They talk about 10 Hadoopable, I'm not sure it's a good word, but 10 problems that could be done by Hadoop. So watch this video, and this is your next assignment. So this video lets you to know what are the application of Hadoop. So I look at your face. Do I give you too much of assignments? So why you got somehow? If it's too much, just let me know. I mean, no worries. So also 3 optional links. So one for a Sqoop user guide. So if you end up working in a mid-sized company, maybe you need to know a Sqoop further than what I teach in this course. So with the Sqoop, just let you to upload your local data into Hadoop file system. Also, there's a book, it's optional, you don't have to purchase it, and some general Hdfs commands. So if you work with the file system directly, which kind of commands you need to know. Okay, any questions so far? Let me wait 1 or 2 minutes for your friends over Zoom to see if you have questions. Then I go to the next PowerPoint. Oh, on the chat room. Yes, Kelly, you can have a question about final project. Okay, so I think your due date for proposal is coming. I assume you guys have similar project in other data analytics courses. Don't reuse your previous projects. And it's okay if you change your topic, but don't miss the due date. try to find, based on the instruction that I posted, try to find the data set, provide some information about the data and variables, and basically what you are going to respond. I mean, what kind of problem you are going to answer through that. So later, for the second or even third delivery, you can basically submit another project or another data set. Yes?
Is there any requirement for
I mean, if you use a very large data set, it's very good for your learning, but you don't have to. So what I usually recommend, maybe 10 variables at least, and at least 1,000 observations. But if you pick larger, you learn better. Also, I got some questions, different tools. Okay, I just want to note the projects. Okay, one of your friends asked about the similarity of the project with band 5573. Again, don't use the same project, use a different one. But basically very similar, but in band 5573, you use NIME, or I mean, you do some visualizations, those kind of things. But the focus of this class is not visualization. So I just want to see if you can import a data set into the Hadoop ecosystem. You learn some Spark. I teach you PySpark, which is a Python version of Spark, but you can learn Spark all by yourself too. So I want to see if you're able to do programming through Hadoop ecosystem. So don't use Tableau for the data set that you have in this project. I mean, Tableau is for a small data set. I teach you some command even for visualization of large data set, but again, these two courses have different goals. Also, I had another figure showing the Hadoop ecosystem. As you see, here I'm not happy because they included Hbase into Hadoop core, but in my point of view, Hadoop core is just distributed file system and Yarn and MapReduce file system. These two. They include the Hbase for the instrument. And okay, so for your project, you can have up to 2 is fine. If you want to make it 3, which is a good activity, I recommend to be in groups of 3. You need to do 2 things. First, I mean, you can pick one environment that I teach you, let's say Databricks, which is the easiest one because we use a cloud version of Hadoop file system. So you just upload in the file system and you don't have any difficulties of working with the Hadoop ecosystem. So on top of that, you need to basically run your code in another environment, let's say local version. So you run your code on local instance. That's actually a good practice. Or you can use Google. So I don't think I have time to teach you how to do Hadoop basically MapReduce or Hadoop ecosystem through Google. So, but you can search for that. Again, I think Shashank mentioned they applied. He worked in a startup that they applied for 120K of grant from Google supercomputer. So they use the facility. So it's a good practice to learn how to work through Google. You do your Spark or any Hadoop activities, either pick whatever technology you see here through that. Also, the second thing, group of 3 should do, I mean, their codes through GitHub and through a group project. So in GitHub, you make an account. Maybe next year I teach that, but I mean, you learn because you're a group of 3, you should learn. So basically, you upload your codes through GitHub and you make some milestones, or you push and pull through multiple people, you commit those kind of things. I think you can learn it easily. So maybe one of you make the mother account and give access to others, so they connect to a repository and they edit there. So I want to see you guys able to work over GitHub and make a group project. And these are good activities. If you later you get a job, these are really good skills that you learn. So how to run codes maybe through Google or AWS or Databricks or local instance. Also working on a group project through GitHub. These are really good. More specifically, for mid-size or large-size companies, they have GitHub or something, private GitHub basically, or another developers, but GitHub is the most common one. So maybe 3 or 4 people work on a project. So they connect to a repository, they submit their codes, comment on it, and just they fix it. So these are actually good practice. So even if group of 1 or 2, if you make through GitHub, I consider some bonus. So it could cover some, if you have some problems in your project, maybe even if group of 1 or 2, at least group of 2, because one student GitHub is not a group project. So GitHub is either group of 2 or 3. And if group of 3, it should be for group of 2, it would be kind of bonus. So, any questions? I don't see anything from your friends over Zoom. So again, in this slide, I go over Hbase. I just skim through because our focus is not Hbase. It's not that much common, but it's one advanced way of managing your Hadoop file system. So in just a nutshell, very basic definition of Hbase, it's just a file NoSQL database. So can anyone tell me what is NoSQL database? I think I mentioned somehow. Yeah. So in SQL, there's a structure. You have tables, you have key column, and you connect column tables through that keyword. But it's not such a thing for NoSQL. The name is very easy, NoSQL. So it's like a text document or image or picture. So it's not the case. So one picture maybe has a much more data than a table, but you have pixels and like those kind of things. So these are the general advantage of Hbase. Is highly available, fault tolerant, very scalable. So basically, if you have much more data, you can just connect more clusters, and Hbase can handle all of the nodes. It's very good for massive tables, very fast one. But 2 major advantages: fault tolerance for a very large data set and scalability. And again, as I said before, since it's connected to distributed file system at the bottom directly, is much faster. So we have a concept of Google's big table. Basically, how it just refers to how a company accomplishes this task. How do you efficiently download web page? How do you store entire internet? How do you index web pages? How do you efficiently search web pages? So for answering this big table concept, Hbase is a really good one. It's a technology basically developed to download whole of the internet, whole accessible internet, everything. So for example, have you guys heard of deep internet? deep internet, deep web.
Oh, yeah,
Huh?
Core. Like the more like harder parts to get into the internet, where it's like use core and all like that. Like that's more encrypted, right?
Yeah, I mean, let's say, yeah, you are right. So let's say in cloud, they have your address, bank account, and maybe I'm not most likely social security, those kind of information. These are very private information, so Google cannot download them. So they are deep web. So they are not first level of internet. So you can log into your cloud data set or table, and you see your address, everything is there, but just accessible by you. So this is deep web. So Hbase is not for downloading everything, just for upper level of web or internet. Anyone heard of dark web? So who wants to say what's dark web?
So it's like another layer beneath the just not indexed by Google part of the internet, where it's like you need to have like a specific like you can't just get to it necessarily. You need a specific type of web browser setup and a specific type of encryption setup. And then there's like the government military that generally for like their files and like I don't know what else is down there, but there's also like drug use stuff down there too, because like no one can really get.
Usually, if it's legitimate, like government or military, usually they say deep web. Dark web is just more like it refers to crimes. So, for example, there's unfortunate stories. So people pay to kill someone over the internet. So they use some cryptocurrencies. So there is one cryptocurrency, they call it Moreno. I think I'm not sure, but I think the US government forbid that. So the good thing about cryptocurrency, you can track who sent money to whom, but in Moreno they can't. So it's a bad thing that. You know, they understand who said to whom, but they don't know the exact name. But let's say, okay, last year, some people, I'm not sure from where, they hijacked the Eastern electric power like network of United States, and they asked government to pay them in Bitcoin, and government paid them easily, and they released the network. But through the internet, you can track that these Bitcoins was paid from this governmental wallet to another wallets. So later they capture all of them, because they know what was the destination and what was the path through them. So they said every Bitcoin who originated from this wallet should be captured, and just these are the US property. Almost all of the cryptocurrencies has this capabilities. So they don't know who received the Bitcoins, but they know these Bitcoins should return back. So nobody can buy anything with them. So I think I already talked about the advantage of Hbase in terms of fault tolerance, speed, being scalable and able to basically handle very large data set. Also very good with columnar databases, that data is in basically the way that they read data through the columns and column families. I go through that quickly. These are some of the speed characteristics of Hbase. So 1,000 seconds per node. So you can handle enormous data set like Facebook message and basically any high throughput processes. So these are the do's and don'ts of the Hbase. So if you need to access to data, read, write, these are really good thing. High amount of transactions, and very simple and basically basic data patterns. What you shouldn't, exactly opposite. So maybe if you want just dump a data set, or basically if you want to do ad hoc analytics, and your data is large but not too large, so if just one node can handle Hbase is not a good one. These are the primary users of Hbase. So eBay, Facebook, Pinterest, Twitter, Yahoo. As you see, all of them have stream data. And I think Twitter data is very clear for you. Some limited number of characters. So the types and pattern of data is easy, and it's not that much flexible. Also, there's some history of Hbase and Hadoop. I think it would be much boring. So as optional reading, just Google about the history of Hbase, Hadoop. Later, I provide some extra readings as optionals, but again, to be a data analyst, you don't need to know too much of history of Hadoop and like Hbase and those things of ecosystem. These are some use cases of Hbase, Facebook, SMS. So in the other countries, instead of saying texting, they say SMS. So SMS just means texting to each other. So location data like Google Map, financial data, network traffic, click streams. So as you see, most of them are related to like stream data. So it's good for high throughput data processing. Data should be simple, read, write, accessing to, and you can easily scalable. But Hbase has some limitations. So it's not fully integrated with SQL. So if you have SQL-based data, maybe you can use other technologies like Impala, Hive, Phoenix. So basically, there are some mediatory technologies between Hbase and SQL. So it has some it's not great for transactional data, and it's not ACID compliant. It stands for atomicity, consistency, isolation, and durability. These are some SQL concepts that I'm pretty sure you're already familiar with them. So these are the essential points that we reviewed so far. Basically, that why we moved to the pair processing and why we use Hadoop. What was the advantage of them? Then we talk about Hadoop ecosystem and the MapReduce as the methodology behind Hadoop ecosystem. Also, we talk about Hbase, what makes Hbase interesting. What is, and we also compare it with the traditional RDBMS databases such as SQL. And we also look at the do's and not do's of Hbase. Okay, so I think the class is getting boring, so let me just go through some. Since our focus is not Hbase, I just want to skim through that, not that much talk about it. But later, if you have time, please look at, if Hbase sounds interesting for you, you can take a look at some details of Hbase. If you have time, we do some experiment through Hbase, but most likely you don't need it in your future job. So look at here. I said the data is in a columnar format. For example, you have a contact information family, and under that family, we have two columns of first and last name. Then you have profile information. It could be profile photo and like some other thing about your grades. So, I mean, for the human, the way that you read the data, maybe you look at the column names and then you look at each row. It just shows how a computer in Hbase, how they act, how they basically conceptual data. So they look at the column families and basically what does each column means. Let me go over one table. I think here it shows you. So for contact info family, we have two columns of first F name, L name, first name, last name. We have a row key, and also we have another column family of profile photo. We just have one column. So these are the current, the current limitation of Hbase cell is just 10 megabytes. I think they are going to increase to 100 megabytes soon, but just keep in mind, don't put too much on each cell. Okay, so we have two general concepts of get and put. Have you heard about them? So basically, let's say I'm a human, this is a server somewhere. So when I type in get, it just means I read the data from my server. Put means I upload the data in the server. But if you look at the server, when I say the get comment to the server just retrieves the data. When I put the data to the server, put for server just means receive the data. So you might see this, technical words a lot. So just keep in mind what does get and put mean. Just mean, you can just consider as a read and upload. Also, I think delete is easy one. Also, we have word of scan. Just scan means all the rows. Just means retrieving all of the rows. I think if you know this from Hbase is enough. Okay, here I put the summary of comparison between RMDBS and Hbase. So the data layout is in RDBMS or even human, what we as a human used to. So you have rows and column oriented. In Hbase, the way that it reads the data through column families, it supports transactions, but Hbase can't. So for the query, we have SQL commands for RDBMS. And even as we said for Hive, Pig, and those technologies, these are same. So with Hbase, we have get, put, and scan. So they have different levels of security. So indexing in RMDBS, so you have indexing, but for Hbase, we just have row indexes. But the last two records just shows why basically Hbase is developed. So, the best RDBMS are good to doing query over terabytes at most, but Hbase is terabytes and even more than that. So it does 1,000 queries per second, but Hbase virtually is unlimited, maybe millions of queries per second. Okay, any questions so far? I know this could be a little boring today, but there are some conceptual matters that we have to go through. Again, for the goal of this course, I don't ask you what is Hbase, what is like columnar data set. It's just for you to understand this concept. Again, if you have time, I put a ton of Hbase slides. Just go through them as optional reading. You can just go to every slide of this PowerPoint and see more details of Hbase. Okay, let's wait 1 minute for your friends over Zoom to see if they have questions. Also here I put some Hbase comments. Seems a little, different from what you used to, but here you can see we have create to make, columns, column families, and basically how to retrieve the data, creating the tables, getting the informational tables, how to disable, delete. Yeah, I put all those comments, but again, these are not what we cover. So these are also some example of working with get, put, and scan. For example, how to read the data, how to scan all the rows. Again, these are not the major part of. Yeah, Hbase is just for your quick review. So if again, this is optional reading for you guys. So in case you have some time, please go to Hbase and read through that.
So you only using HBase?
Yeah, we don't use it in this class. If at the end I have some little time, I maybe spend, but again, Hbase is, I think it's good for information systems students. It's not that much for analytics students, because for you, it's good to know some data management skills, but like Hbase is just mostly and like more information system students. So these are some major objectives that later we cover them. So basically, can anyone answer the first question? I think I explained a little bit of what Apache Spark is and what problems it solves and why you would want to use it. Maybe if you look at this figure, so the first question of the answer of the first question, basically, it just to advanced analytics through, in Hadoop ecosystem. So if you want to do advanced analytics for very large data sets through Hadoop ecosystem, you use Spark, like PySpark. So why you want to use it? Because otherwise you should do everything from scratch. So doing so much of MapReduce. So for somebody who's expertise in analytics, you don't want to spend too much time to do what is this MapReduce, how to upload the files. You just more likely you're focused on your analytics part. So it's basically the language for your major. So it used to be just through RDDs, basically resilient distributed data set, but it's just fading out. And more recently, people just do Spark through data frames. Maybe if I have time, a little talk about RDDs, but they are just fading out. besides, they have some basically good capability to work with a stream of data. A stream of data could be like text document, tweets, some data that comes in a stream. I think I talked about it a little bit in one of your sessions. So traditionally, I mean, the process was bound through the process power. So for doing a larger processes, they just try to have a larger computers, larger, like, even you might remember we had Core i2, Core i3, Core i5, even I think we have Core i9 somehow now. So one approach was just extending your computing power. But we talk about how we can use parallel processing, and Hadoop ecosystem is basically developed for that. So let me read this quote from Grace Hopper. She's very well-known computer scientist. In pioneer days, they used oxes for heavy pulling. And when one ox couldn't budge a log, we didn't try to grow a larger ox. We shouldn't be trying for bigger computers, but for more system of computers. She's really famous. I recommend just maybe you can YouTube and see some videos about her. She's really outstanding. Actually, since I already covered them, so let me just skim through. Basically, this Apache Spark is started in 2009, and the way that they process the data was through RDDs. This is just fading out. So when if later you Google about your question Spark, see some works that made after 2018. Before that, there's so much of RDDs, so it's very hard to figure out what they did. That kind of data management and Spark processing faded out. So don't look over old. So for Python, maybe if you see something they made in 2014, that's still relevant, but it's not the case for Spark. So these are the pioneers of Apache project, and they are basically they are involved heavily. So one of them, University of Berkeley, Intel, Groupon, Databricks, Yahoo, and Cloudera. So our earlier experiment was through Cloudera, but later we go over Databricks. That's a cloud-based Hadoop ecosystem provider that you can run your Spark code much easier. Besides, Spark has some capabilities to work with the Hadoop distributed file system directly. But if you want to go in that way, your program might be much harder because it should take care of so much of MapReduce calculations. Instead, you can connect a Spark to Yarn, and Yarn takes care of the heavy part of like doing MapReduce and talking with the file system. So talk about scalability, lots of data. So these are some activities that later you learn how to do through PySpark. For example, how to extract, transfer, load, text mining. So I will spend at least one or two sessions for do text mining through PySpark. Index building, we have some. We create some graphs and we do some visualizations. Pattern recognition might be, I'm not sure if we have time. So prediction models, sentiment analysis, and risk assessment. So these are main topics that I cover in Spark, PySpark, and basically, I think you guys took, have you guys had Jupyter notebooks for your Python? So it's how you learn Python in school. So I used to teach through Jupyter. I'm not sure the next, so basically similar to Jupyter notebooks. So if later we work with the Databricks, they did everything from basically Hdfs, Yarn, and major Spark parts. So you do some Spark programming through some Jupyter notebooks, similar to Jupyter notebooks, not exactly, but just it's the closest things that I tell you. So no worries. Later you can do very cool things with the less difficulties of technology part. These are major benefits of Spark. You can do very practical analysis, much lower cost, less time, greater flexibility, and nonlinear scalability. So just see the differences of coding in Spark and just do everything in Hadoop ecosystem. Just look at the differences in terms of lines. So in 4 lines of Spark, it's equivalent, 30 lines of working with the Hadoop directly. And we had some difficult experiment in one of your assignments. So for just finding the distribution of movie rates and those kind of things, you have to write multiple lines of codes, but you do even much more complex through Spark and makes your life much easier. So what I recommend for next classes, try to have a Spark on your Hadoop ecosystem. Let me see, maybe I teach you the next how to install it. So you can, Databricks is like some cloud-based Jupyter notebooks. You can have on the local system and learn that. It's a really good learning if you do through your local system, but you don't have to. Again, we have another class that you do some Spark, PySpark experiences through AWS. Any questions? Let me wait for your friends over Zoom for 1 minute. Yeah, I dedicated some minutes for your questions, but it seems today was not that much interesting, so not too much of a question. Okay, from next class, we go a little more in the hands-on experiences again. I do some heavy parts early in the semester, like how to do installation, how to do this and that. So later in the remaining of semester, I assume you have some exams in other courses, so I don't want you to spend too much time on installing Hadoop and like VirtualBox. So for your assignments, since I put some due dates for your first assignments that related to local installation, VirtualBox. So I extend the due date by end of, let's say not end of September, by mid-October, you can submit them, because some of you had to buy a new computer, some of you had some VirtualBox problems and installation issues. So also there's a due date, you can submit by October 15. Now we are in this. So because these are not the major focus of this class, but if you can do it, please do it now, because by October 15, you might have other midterms, some other classes ask you too many things. So if you do earlier, much better. Okay, it seems we don't have any questions. So that's for today. So for people over Zoom, if you come next classes, we have so much of chocolates remain, so you can pick them. Thank you very much and have a good rest of the day. Sure.